Hi guys, welcome back. So we are still looking at evaluating series, right? Or which is actually under number patterns. We looked at what a sequence is and what a series is, but only under the concept of arithmetic, right? Which has to do with addition and subtraction. Now let's look at when it has to do with multiplication and division, which we then going to call a geometric sequence and a geometric series. So for now, let's look at what is a geometric sequence. So with a geometric sequence, it will then be where the ratio between consecutive terms remains constant. So the ratio is normally given by a small letter r, which is the same as you saying T2 divided by T1, which must be equal to T3 divided by T2, which must be equals to T4 divided by T3 continuously. So you see, as long as it's consecutive terms, then you will get it correct. Now we have a series as well under the concept of a geometric sequence. This will be the sum of an ordered list of numbers. Remember, we spoke about that. With a geometric series will then be when we are adding the terms of a geometric sequence. Now with a geometric series, we also have a formula to calculate this. And the formula to calculate this will be normally when you know the number of terms. With this one, then it's only when we know the number of terms, really, which will then be Sn is equals to a into r to the exponent of n minus 1 over r minus 1. But r must never be equal to 1, because you know that will mean that the denominator will be 0. Now just on this, I want to make a point here. I know that there are two formulas on the formula sheet that have to do with this, right? And people normally ask me which one to use between the two. Honestly, either one of them is correct. Don't look at this thing of if r is between that and that. No, both of them will be correct as long as you pay attention to the signs, because at times the other formula will give you a denominator which is a negative. Some people don't really know how to work with the negative denominator. That's why they choose which one between the two. Or the other one will give you a denominator that is a fraction. Some people don't know how to work with that. But remember, you have a calculator, and this I will never say to you without the use of a calculator. So either or, it will still give you the same answer. Just make sure that you pay attention to your signs, right? So now we also have some questions that you can do here. It says calculate the sum of the geometric series. The sum of the geometric series up to how many terms? 10 of them, right? So I said to you the formula will be Sn is equals to a into r to the n minus 1 all over r minus 1. You don't then need to say r must not be equal to 1. I'm just telling you that if I give you, excuse me, if I give you a sequence or a series and then you find r as 1, then you cannot do anything that has to do with a sum, please. Right? That's what I'm just trying to tell you, that my restriction will always be that. So r must either be greater than 1 or less than 1, but not equal to 1. So here my r will be the 6 divided by 2, which will give me 3, and it will be the 18 divided by 6, which will also be 3. So that's my common ratio. The number of terms will be the 10 that I have there, and then the value of a will be equals to the 2 there. Then I substitute, right? So this will be my a value, as I said, is 2, open the bracket. My r is 3, not squared, and I'm already thinking about squared here. The n will be the number of terms, right, which is 10, then minus 1 over 3 minus 1. And you can then go straight to your calculator, guys. And on the calculator, if you want to solve this, it will be 2, open the bracket, 3 to the exponent of 10 minus 1. You just put it as is, right? 3 minus 1 is just 2. I can just leave it like that, which is 59,048. So this is 59,048. 48 or 84? Let me just, yes, 48. So this is 48. Now, what you then also need to look at is the concept of a sigma notation that has to do with this one. Right? Remember we said sigma notation is about the sum of n terms, right? Even with this one, for you to find n, you still apply the same rule. So my n value will still be 12 minus the 3 plus a constant which is 1. 12 minus 3, last time I checked, it's supposed to be 9, unless you're now using a calculator that does not look like mine, plus 1, it will then give me 10 there. I'm just kidding, guys. And then from there, the value of a, you will need to expand this thing, right? But the first term is at 3. So this is 2 to the exponent of 3 minus 1. The second term will be 2 to the exponent of 4 minus 1. The third term will be 2 to the exponent of 5 minus 1, like that, right? So it means 3 minus 1 is 2. This will give me 4. 4 minus 1 will be 3. This will give me 8. 5 minus 1 is 4. This will give me 16. So if I divide here, I will have then 2. If I divide there, I will have 2, right? So I go straight to my formula. So remember, the formula is Sn is equal to a r to the exponent of n minus 1 over r minus 1. Then let's go back and just make sure that we know what our terms are. The n is 10, the a value is the 4, and then the r value is 2. So this is 4, open the bracket, that is 2 to the exponent of 10 minus 1, close the bracket, all over my r value there is 2 minus 1. Then you go straight to your formula, right? Or your calculator, I mean. So it's 4, open the bracket, 2 to the exponent of 10, and then you subtract the 1, minus 1, close the bracket, over 2 minus 1 is just 1. Then you find what your answer, which is 4,092. So this will be 4,092, and that will be the answer there. So let me just give you a few steps that I think are very important for you to do both the things that we did in the first segment and in this segment. When dealing with the sigma notation, right? When dealing with sigma notation, these are just pointers that you need to try and look at whenever you are doing this. Number one, make sure that you expand, right? Meaning when I say expand, you find the first 3 terms, right? That's what you do. We are just summarizing the concept of sigma notation because I know that it's a bit of a problem for you to do this one. Then number 2, you find n, right? Find n. Remember with n, it is actually given by the top minus the bottom plus 1. It's a general formula, right? You find n using that formula. Number 3, you decide which sequence it is that you are dealing with, right? Normally when the variable is an exponent, you already know it's a geometric. So I will just say use I will call it just AB, which means appropriate sum formula, right? Make sure that you use the appropriate sum formula, and then you will be done from that. Please press your calculator, guys, when you're doing this. I know at times we try by all means to do mental maths, but here it is not necessary for you to do that. You can just press your calculator and everything will go right for you. Now, the other thing will be when they say to you then write the series in sigma notation. That's another thing. Writing the series in sigma notation, then you actually don't follow these steps that I have here. Instead of you expanding, it will already be expanded for you. You then definitely need to know what the number of terms, right? But instead of expanding, your first step will be to find Tn, right? Which is the value of what is the general term. So if you look at all the questions I've given you, this here, represents Tn of a geometric series. So you need to make sure that that's the first thing that you find. And then from there, step number 2 is the same as what is up there. You find the number of terms, and then lastly, you express it as sigma notation. And then you'll be fine. Your n value is there. With you guys, when they want you to find it as a sigma notation, your k value here is always equal to 1. You don't play around with, let me jump and make it 2. Because if I say you have a freedom there, then I will be having 20 of you in one class. One will have k is equals to 1. The other one will have k is equals to 5. The other one will want to be creative and then say k is equals to 10. So all of us, if we are writing something in sigma notation, we always use k is equals to 1. And then that will make it easier for us. So guys, I hope that clarifies a few things here that you need to look at, please. Remember, sigma notation is how we shorten writing a list of values and adding them together. We shorten it using the Greek sign that looks like an E, right? And then remember the 2 formulas for an arithmetic series and for a geometric series. There's also a quadratic series, but a quadratic series, it will normally be when the number of terms is normally not even more than 15 or not more than 10, because you need to add them manually. You don't have a formula for a sum of a quadratic pattern, so you will just add them as individual digits and get the answer there. Guys, for now, let's just walk around the house a bit so that we can get some fresh air and get some blood flowing in our mind and our body. But for now, let's quickly take an ad break and I'll be back with some more maths.